Warm greetings. Welcome for online video session of software engineering. Myself Jagadish, Department of Computer Science and Engineering, Associate Professor, Canara Engineering College, Bandpal. Till now, we have seen three modules from in the software engineering. In the first module, we saw the introduction to software engineering, then requirement engineering in the module 1. In module 2, we saw about object oriented methodologies. Then in module 3, we saw the system modeling. Here we'll continue the online mode session of module 4. The module 4 is of software testing and software evaluation. So till now we have shown the design of a first we saw the requirement specification as well as customer. Then after that we designed the software based on the requirement of the customer. Then we start implementing. Then we draw the system modeling based on the requirement of the customer. Then after doing the requirement of the after considering the requirement of the customer, then it is implementation. So after doing the implementation in the last there is after the designing, then implementation, then it is the testing, then evaluation, then there is evaluation in sense delivering the product to the customer. So this is the chapter number 8, software testing, in the Somerville textbook. So in this we'll cover the topics: development testing, test driven development, then release testing, then user testing. So development testing, test driven development, release testing and user testing. These are the topics that we cover in this chapter. That is, we have a two chapter. One is software testing and software evaluation. So in the software testing, we'll see these four topics. Coming to the testing, software testing, that is, testing is intended to show that program does what it is intended to do and to discover the program defect before it is used. So it discovers the program defects before it is put into use. Testing is intended to show that a program does what it is intended to do. So testing is nothing but, so you have designed a product. Before delivering to the product to the customer, you will have a blueprint of what there is application or a software has to do, that is delivering to the before delivering to the customer. So that you have to test that product before delivering to the customer. So whether the input what is given by the implementation team to test the product, whether you are getting the output as per as customer, that is given by the implementation team. That is actually testing. So next, it is when you test a software, you execute a program using artificial data, because the test engineer doesn't have any knowledge about the application. So he or she will give the data as on his wishes. So that is by giving a some other data which is not related to the application. So for example, you can consider addition of two numbers. Then the test engineer can give a addition of two number. He can give any sort of. So for example, he can give a character, or he can give a there is decimal points. Some but actually the programmer knows whether it is work for a that is real number or it is a decimal number, something related to that. Okay, so that is when you test, you execute the program using artificial data, not the actual data. This is what important. This is not going to work actual data. So, and this is, we're going to call this as a black box testing also. So black box testing is we have two types of testing. One is black box and white box. So black box testing, it involves testing the testing a system with no prior knowledge of the software or a application. The tester doesn't have a prior knowledge on the application. So a tester provides an input and absorbs the output generated by the system under test, and this is something we call as a black box testing. So white box testing is the tester will have know the knowledge about the application, what type of data has to be given and what as expected the output. That is called white box testing. So usually the developers always, that is testing engineers always uses a black box testing. So this is what the difference between black box and white box. And usually while testing, they usually use the artificial data, that is nothing but the black box testing. You check the results of the test run for errors. So what purpose you have to test the software? That is to test the to check the errors, any anomalies or information about the programs of non-functional attributes. So non-functional attributes, something like any that is policies or any something related to the there is something related to the external attributes have been involved in the application, etc. So main thing is to run the there is the system, there is the application to check the errors in the system, that is application, and it can reveal the presence of an errors, not their absence. So you can identify the errors that is in the system, that is in the application, but not their absence. Testing is a part of general verification and validation process. So usually we call testing also capital V and V process. So capital V and capital V process, V and V process also. So is nothing but verification and validation. So verification in the sense whether the application or software is being designed as per as a customer by giving a artificial output, and validation in the sense in the particular field, whether the correct data will be given. For example, you can see in the there is integer field, whether integer element will be taken or not. Other than integer, whether it takes decimal points or any character, it should not take. That's a validation, because it is been that particular field is designed only for the integer, that it has to take only integer element. If the field is designed for the password and it should be not visible, then and if the password is designed only for 6 character, it has to take only the 6 character, not more than 6 characters. So such way of such type of is called as a validation. And if the password is designed both alphanumeric, then it has to check for alphanumeric. Whether if you do only for the numbers, then you should not take the numbers. It has to pop up the message that only a character, only the number has been typed, or it is only both alphanumeric number has to be typed. The such type of information has to display when only the number or character is being given in the particular field. So such type we will call as a validation. So which includes static validation technique. So testing is a part of more general is a verification and a validation, which also includes static validation technique. So program testing goals. What are the testing goals? It is demonstrate to the developer and the customer that the software meets its requirement. So make a note that developer won't test the software. The test engineer will be there separately. He has to test in front of the developer as well as customer that the software meets its requirement. So that's what that is testing goal of the software. And here you can consider there is two distinct goals of the testing process. So what are that? And in the examination also they can ask what are the testing process, that is distinct goals of the testing process. So one is for customer software, for custom software, this means that there should be at least one test for every requirement in the requirement documents. For generic software product, it means that there should be a test for all of the system features plus combination of these features that will incorporate in the product release. This is what for the distinct goal of the first distinct goal of the software process or testing process. One is that is for custom software there should be at least one test for every requirement in the requirement document. So there is at least one test as per as, for example, if you have a 4 stages of a software that what you design. So in each stages there should be a one test at least as per as customer requirement. And in the generic product there will also be a same as it is what we have did in the custom software, along with combination of all the stages we have to check once again before the product released to the customer. To discover the situation in which behavior of the software is incorrect, undesirable, or does not conform to its specification. So defect testing is concerned with rooting out undesirable system behavior such as system crashes, unwanted interaction with other system, incorrect computation, and data corruption. So to discover the situation in the behavior of software is incorrect, undesirable, or does not conform to its specification. As per as customer specification, if it is not made, then the software is incorrect. If the defect testing is concerned with the rooting out the system behaves such as system crashes, unwanted interaction with other systems. So if there is a defect testing is concerned means checking the software from the root, that is from the beginning, and at that time there will be changes in the system behavior. There is nothing but application. At that time system get crashes because if you not design the product correctly, then there will be chances of system crashes because you are given inputs which is not related to the customer requirement, and even the developer has not designed the product properly as per as customer requirement. Then as per as documentation what a test engineer's goal, if he gives the input as per as that, but the design is entirely different, then at that time there is a chances of system crashes, as well as some computation problem, data corruption, etc. will be happen. So this is what the testing goes. And validation and defect testing. So validation is the that is, you expect the system to perform correctly using a given set of test cases that reflects the system expected use. So validation testing, that's what I said. You are doing if you want to enter the password 6 character or 8 characters, that not more than that, then it's a validation testing is been doing there. So you can check it in the any of the websites where the even in the any of like Google also, if the character you have to enter, if you enter only 4 character, then it gives a error because it's been checked for the minimum 6 character. And in the some other application, you can see the starting letter should be a capital letter. When you give a small letter, then it shows some error messages. So that is what the validation. So it is expected, what it is expected, and that has to be given in the field. So that is what validation testing says. And second goals lead to the defect testing. The test cases are designed to expose the defects. The test cases in defect testing can be deliberately and did not reflect how system is normally used. So test cases are designed to expose the defects. So you have to find some error in the system, that is in the software. So the test cases has to be designed in such a way that you have to defect, that is you have to defect the testing, that is some error has to be found out in that cases. So that did not reflect how system is normally used. So this is what validation as well as defect testing. Next, it is a testing process goals. In the testing process goal, it is a validation testing and defect testing. And validation testing is to demonstrate to the developer and the system customer that the software meets its requirement. So to demonstrate to the developer and the system customer that the software meets its requirement, that is a validation testing. A successful test shows that system operates as intended. Successful test shows that system operates correctly. Okay, validation testing to demonstrate to the developer and the system customer that the software meets its requirement. A successful test shows that the system operates as intended. Defect testing to discover the faults or defects in software where its behavior is incorrect or not in its specification. A successful test is a test that makes the system perform incorrectly and so expose a defect in the system. So defect testing, we are making the system to perform incorrectly, and so that it exposes the defects in the system. So that is what the defect testing as well as validation technique goes. Okay. So next, it is, see, you can see here there is a block diagram what they have given. This is a system where you give a input test data and output test data. So this is what the anomalous behavior input causing, that is it creates we are giving a wrong input. See in this these are all correct input, and this is only the one wrong input that is causes anomalous behavior. So if the input which you give, it produces the correct output, at this that is this side, and the input what you gave wrong input, produces a wrong output. So output which reveals the presence of the defects. So always you have to check if you give a correct input, whether you're getting the correct output. Also, if you give the wrong input, whether you're getting the wrong output, that has to be checked. So in the always that has to be checked in the software testing. So at that time we can decide the system or an software what the design by software engineer is a correct input, that is correct software. So this is what the model has been designed to check the correct input as well as to check the correct output, or as well as to check if you give a wrong input, then you get a wrong output. So this is the diagram, shows the input output model for the programming testing. So next comes is a validation as well as verification. Verification is, are we building the product right, is the verification. The software should confirm its specification. The software should confirm its specification as per as the requirement of the requirement engineer. Are we building the product right? Validation is, are we building the right product? The software should do what the user really requires. So validation is, are we building the right product? Verification is, are we building the product right? Okay, this is are the two, whether is verification and validation. Are we building the product right? Validation, are we building the right product? These are the two that is validation and verification. So validation and verification are the concern with checking that the software has been developed meets its specification and deliver it the functionality expected by the people by paying for the software. That's the validation verification. So main aim of the, see I said the beginning itself, so verification and validation we call V and VA. And aim of the V and V is to establish a confidence that the system is fit for purpose. So you have designed a product, then you have checked whether it's been ready to deliver to the customer, that is fit for the what it is been designed or what purpose it has been designed, whether it is fit for the that purpose has to be checked in the that is the main of the aim of the verification validation. Depends on the system purpose, user expectation and marketing the environment. So software purpose, user expectation, marketing environment. Software purpose, the level of confidence depends on how critical the software is to an organization. Software purpose is level of confidence depends on how critical the software is to an organization. That is more critical the software, the more important that is reliable. For example, you can see level of confidence required for software is used to control the safety of the critical system is much higher than the required for prototype. So that is what the software purpose. And user expectation is that is user expectation may have a low expectation of certain kinds of software. So user may have a low expectation of certain kinds of software. They are not surprised when their software fails also. That is because the expectation is a low, that is because of the software quality, they're not surprised when the software fails. Okay, when even though when this new system is installed, user may tolerate, the user may having a tolerate the failure also. Whenever you install a new software to the system, at that time if it is get failure, it may tolerate also, because user expectation is the very low kind of expectation on the software, and because of the benefits of the use of the outweigh the cost of the failure is a that is since it is system is failed, or so installation of the software is failed, even the cost of the that is of the system will be also be very less for the customer also. And next, marketing environment. When a system is marketed, the seller of the system must take into that is account competing product, the price that the customers are willing to pay for a system, and is required schedule for delivering the system. So getting a product to the market early may be more important than finding a defects in the program. So some of the that is customer will have a competition with the other other software company. So he or she may want to release a product as early as possible than the other person. So whether it's working condition or in a not working condition, whether they have designed a product that correctly, or whether designing the product for the user friendly, they won't consider anything, all those things. They have a competition between a company as well as B company. So whichever the company releases a product in the market, then the product usually most of the that is users always take it into consider the product which is having a less money. Usually the people will going to purchase that product because the money is very less. They won't think about the specification, whether the life of the product, etc. So that is usually not only in the software, you can see in most of the other products in the market. So that is what the verification and validation is confidence depends on product. So next it is a inspection and testing. So software inspection is concerned with the analysis of the static system representation to discover the problems. Maybe a tool based document as well as coding analysis. Software testing concerned with the exercising and observing the product behavior. So is concerned with the analysis of the static system representation to discover the problem, that is static verification, and software testing is concerned with the exercising and observing the product behavior. The system is executed with test data and its operation behavior is observed in the software testing. Whereas in the software inspection, it may be a supplementary by tool based on document and code analysis. So inspection in the sense whether the product, for what purpose it has been designed, whether it is doing that job, is being checked in the software inspection. Whether they have followed the software engineering ethics, whether they have followed the rules and regulation as per a software product company, etc. And for what purpose it has been designed, whether it is being performing the say operation, that has been all analyzed in the software inspection. Inspection and testing. In the inspection, you can see the requirement specification, architecture, UML design models, database schema, and programs. So in the requirement specification, you have system prototype. That is, what are the steps, or what are the specification has to be taken care before designing the application. That is, system prototype has been checked, is designed, and in the testing part, it will check both the program along with the system prototype. Right. For example, you can consider before you joining a engineering, you have to go through the PUC as well as you have to go through the CET, right? So after completion of the that is to get a seat in the engineering colleges, they will check which college he has joined, and the marks card whatever you have produced to the college will be checked along with the USN what is being issued by the PU board, as well as the rank what you got from the CET will be verified both in the college as well as in the board. So this is what the testing is been done. Okay, so this is what the inspection and testing. Requirement specification, software architecture, UML design model, database schema and programs. That is the inspection has been done, and in the testing part it will check, cross verify with the test the system prototype along with the program whether it meets the both the requirement of the customer. Then it has been released. Okay, and software inspection. In the software inspection, it discovers the people examining the source representation with aim of discovering the defects. Discovering the defects. Inspection not require the execution of a system, so may be used before implementation. Inspection not require execution of a system, so may be used before implementation. They may be applied to any representation of the system, that is requirements, design, configuration data, test data. They may be applied to any representation. So if the inspection is required, it can be checked in the requirement field, that is requirement of the specification. If the inspection is required in the design part, that is they can apply it in the design part. Also in the implementation data, they can involve in the in implementation also, or they can involve, the inspection can be also involved in the testing data, because inspection can be but not only in the that is final product, it can be also checked in any part of the field of the design of the software. So they have shown to be an effective technique for discovering the problem errors. So the inspection is one of the best technique to discover the problems or errors that is in the program. So these are the steps has been taken in the software inspection. That is they involve a people examining the source. Inspection not require execution. They may be applied in any of the requirements. They have shown an effective technique for discovering a program errors. What are the advantages of inspection? So during testing, error can mask other errors. So during testing part, the errors can be hidden or hide with the other errors, because inspection is a static process. You do not have to concern with the interaction between the errors. So inspection is entirely different. It is a static process. You do not have to concern with the interaction between the errors. So incomplete version of the system can be inspected without additional cost. Incomplete version of a system can be inspected without additional cost. You see, for example, the software developer design a product, and which is not a complete product, he may deliver the product to the next stages. So inspection team can verify the errors in the program or in the application, and whether it not met the requirement, because which is not identified by the testing team, he can be want to add some other there is program or some other application, then which is incomplete. So to add to make it complete, there is will be no additional cost for the customer. So that is one of the advantages for the inspection. If a program is incomplete, then you need to develop a specialized test to test the parts that are available, as well as searching for a program defects. And inspection can also be considered the quality attributes of a program. So to search a program defect, not only testing part, even inspection plays a very vital role to find a problem in the system. So that is one of the advantages of having a inspection in the testing part also. Inspection, that is program inspections are an old idea, and they have been several studies as well as experiments have been demonstrated in the inspection, which will be more effective to discover a defects in the program testing also. So these are the some of the there is we've been had on advantage if you have a inspection. So they will have a more effective on the discovering a problems in the testing. Inspection and testings are complementary and not an opposing verification technique. Both are same, it's not opposing, and both should be used during verification and validation process. Inspection can check conformance with the specification but not conformance with the customer's real requirement. So inspection doesn't have the a customer requirement, but check the conformance with the specification of the software engineer. Inspections cannot check non-functional characteristics such as performances, usability, maintainability, etc. So these are the inspections add-on advantage in the testing part. So model of the software testing process. So model of the software testing process, very important question in the examination also. So you can see the design test, prepare test data, run program with test data, compare results to test cases. So design a test cases. So you will design a test cases and will be given to the prepared test data. So in the prepared test data will run with the there is actual test data, that is as per customer test data, and test data will be prepared by the then will be given an input to the run program. So after running you test the results, no, so that compare the results of the test cases. So actual test cases will be verified with the results of the test cases. So the results of the what you run the program will be compared with the test cases of the design test cases with the run there is test data of the program. After there is been verified, you got the same result, then you have to design a report of the entire application. So design test cases will be the input to the prepared test data. So you have designed test cases. So test cases what you have designed, and there is input, the same the output has to be verified with the that is compare the result with the test cases. That is a program whatever you run, what the output you got will be verified with the test cases also. If you get the similarity, then you start reporting the entire application. So this is what the a model of the software testing process. Very important question in the examination point of view also. So next it is a stages of software testing. So you have a development testing, release testing, user testing. So stages where the system is tested during the development to discover the bugs and defects. There is nothing but errors. So development testing. So software engineers implementation team design the product and it is being released or given back to the testing team. So testing team, you have a various stages. We have a development testing, release testing, user testing. In the development testing, the system is tested during the development. That is nothing but the program to discover the errors and the defects or errors, bugs, defects in the program. Release, this is done by the software engineers, that is test engineers, before releasing the product to the customer. So if they find any errors in the system, then they return back this application back to the design and implementation to rectify the defects. So once if they rectify, then the product has to go through the same procedure, 1, 2 and 3 stages. So once again they have to develop, the development testing has to go through. Even at that time also, if they find any errors, then once again return back the product to the previous stages, then rectify that errors. In the development testing, there is a customer won't be with the development testing. So in the release testing, it is a very separate testing team test the complete version of the system before it is released to the users. So this is something like a filter. So first filter, if you find any errors, return back. Even though by mistake, if you not able to find the errors, then release testing team will be find if at that time also, if you find any error, then before releasing to the customer, if you find any error, then release testing team we has to send back to the development testing by finding out the errors in the system and return back to the and try to clear the errors. So this is before releasing product to the customer. User testing, that is where user or end user of a system test the system in their own environment. So in their own environment, in the sense by giving their own inputs, whatever the product, that is whatever the input has to be given for the particular application in front of the user has been tested. That is your user testing. Okay, so these are the 3 stages of the product, that is testing before developing, before giving back to the product to the customer. So before going to the development testing, so we'll recap. So what are the things, or what are the topics that we have covered, and we cover the definition of testing, and we have covered the testing process. There is 2 distinct goals. That is very important question also. Then we saw about the input and output model of the program testing. That is if you give a correct input, then you have to get a correct output in the system. If you give a wrong input, then if you have to get a wrong output only. So then only it is confirmed that your testing has been done correctly. So when the next we saw about verification and validation. So in the verification, that is are we building the product right, that is verification we also, and validation we check are we building the product right. So the main aim of the verification, that is whether the software meets functional and non-functional requirements, and there is the main aim of the validation is to ensure the meets the whether the customer expectation. That's what the validation and verification aim. And next we saw about the software purpose and user expectation, and that is marketing environment. Then we saw the inspection and testing diagram. In the inspection, we can check any stages or any we can check the inspection in any stages, like environment specification, software architecture, UML design model, or database designs program. And in the testing part, there is what that is expected by the customer in the specification, whether we have met the same thing in the program is being checked in the testing part. And we saw the advantages of using a inspection testing. Then we saw the that is model of the software testing process. And in the software testing process, that we go through 3 stages. One is development testing, release testing, and user testing. So next we'll see the development testing. In the development testing, it includes all testing activities that are carried out by the team developing the system. So all testing activities, maybe unit testing. See, whenever you develop a product, you have a model, submodels, components, subcomponents, etc. Right? So same way in the development of a testing, you have to test different stages. like that we saw unit testing, component testing, and system testing. So in the unit testing is a individual program units or object classes are tested. Before designing any of the product, you will have a number of classes, number of templates, and the number of objects will be created, and you have to test each individual object classes, and that is been done by the unit testing. Unit testing should focus us on the functionality of the objects as well as methods, etc. So that is what unit testing. You are not testing the entire product at a time. You are testing the individually. You are testing the function. For example, you can consider you have a number of functions to design a application. So you are testing a individual function, whether that function meets the requirement of the for what purpose the function has been designed. So you can consider in your application you have around 10 fields. For 10 fields, for example, to first field, consider the name of the student, age of the student, etc. So in that function, whether that particular field is being working properly or not. For example, in the name you should give a 10 character. So whether it takes that is more than 10 characters or less than 10 characters it takes or not, you have to check it. So such type of functions will have that is what we check, that is individual function is called unit function, unit testing. And component testing, here you can see the several individual units are integrated. So for example, if you design a application of 10 functions you have designed, so integrating a 5 function makes a component, one component. So integrating all 5 function and producing the output, corresponding output or not, is being checked in the that is component testing. Component testing should focus us on the testing the component interfaces, that is interfaces between the one function to the other function has to be checked in the component testing. And in the system testing, where all the components to design a product is being integrated together and makes a one system, and checking all the functions in the system testing is being done, where all the components in the systems are integrated and the system is tested as a whole. And system testing should focus us on the component interaction. So this is what the development testing. So development testing is primarily a defect testing process, okay, where the aim of the testing is to discover the errors in the software. Development testing main is to check the error in the software. So this is what the development testing. So we'll see a individual unit testing, component testing, and system testing individually. And previously what we saw, the development testing, even in the examination they can ask what give a 3 level of granularity development testing. So granularity development testing, it can be asked. So granularity development testing is unit testing, component testing, and system testing. Once again I am repeating very important question. So they can ask what are the various stages of the development testing, or what are the 3 levels of granularity development testing. So one is unit testing, component testing, system testing. Make a note on this also. Next, coming to the unit testing, is a process of testing the program component such as methods, object classes, attributes, etc. And individual functions or a method that is within the object classes with several attributes, and components with defined interfaces used to access their functionality. Okay, that is what a unit testing. When you are testing the object classes, you should design your test to provide the coverage of all the features of the object. That means test all the operations associated with the object, and there is all the operations associated with the object. For example, if you have a if you see in the object, there is a object of the Windows system. You have a several objects as well as several for example, you have inheritance, so many features of the parent classes, and whatever the that is test is been done into parent, then the same test also has to be done to the child class also, because it has been inherited the all features of the parent classes. It has to associated with all the results, test all the operations associated with the object, and setting an setting testing all the operation associated with an object, and setting an interrogate all the object attributes, exercising the objects in all the possible states. So inheritance makes it more difficult to design the object class test, as an information to test in the test is not localized. So this is what there is object classes is involved while testing the unit testing. So weather station object interfaces. So you can see the example in the weather station. So identify. So you have a report weather object. There is function report status, power save, remote. So all this, see, all these functions what we have designed are all interrelated. Okay, so when you test the this individual, if you got any error, it is related to all other functions. So in such a way that unit testing means you have to check the individual, and if you find any error, then you have to rectify there itself. Then you have to check once again all there is object classes. This is entire thing is a one class. So after that you have to check entirely one whole class for the testing part. So weather station testing need to define the test cases for the report weather. So calibrated test startup and shutdown. Using a state model, identify the sequence of the state transition to be tested. So for example, shutdown, running and shutdown. Configuring running, testing, transmitting and running. These are the stages has to be followed while testing. Okay, so after shutdown it has to run, then once again it has to shut down, and running, collecting, running, summarizing, transmitting and running. So these are the various testing has to be taken places in the weather station. Yes, in the automated testing, it is involved without a human. So there will be a separate template which has been designed. So what actually input has to be given, and what output is being expected, and what are the interfaces are involved, etc. are all been there will be separate script is being designed to check the software product. So whenever possible, unit testing should be automated, so that test can run and check without a human or manual. In automated unit testing, you make use of the test automation frameworks. So there will be separate unit or separate template will be written to run your program test. Unit testing framework provides a generic test classes that you extend to create a test cases. So they can then run all of the tests that you have implemented and report through the graphical user interfaces on success of otherwise of the tests. So automated test is nothing but Human is not at all involved, but they will be designing a separate coding will be done to test the product. Automated test components, a setup part where you initialize the system with the test case, namely input and expected output. A call part where you call the objects or a method to be tested. An assertion part where you compare the result of the call with the expected result and evaluate to true. The test can be or test has been successful. If false, then it has been failed. So we've been designing a product by making use of the tool. So if you got the output as expected, as what you are designed in the script language, if you not got the output, then it has been messaged as a fail. If you got the result as expected, then you have to message it that the testing part is successful. So this is what actually automated tester component. And next there is a unit test cases. We'll see it in the next classes. If you have any doubt, you can clarify in the online classes. And wherever I stressed is important, please concentrate on that. And this model is especially is easy, and the content what we have took for this online session is from the AN Somerville 9th edition software engineering. And if you have any doubt, you can get it clear in the online classes. Thank you all.